Hello everyone and welcome to another webinar series of Circuit Digest. So in this webinar series, we'll be discussing about the STM32WL, which is a long-range wireless microcontroller series from STMicroelectronics. We'll take a deeper look into this controller, and we have Mr. Benjamin, who's the product line manager of STMicroelectronics. We'll be hearing from him about the new features that has been added to this STM32WL microcontrollers, its compatibility, and how it's going to make an impact into the LPWAN community. So hi Benjamin, thank you so much for joining us today.
Hi, thank you very much for having me.
Yeah, so how are you doing?
I am very fine, thank you. Working from home as most of the people right now. I guess on your side too, maybe?
Yes, correct. So even we are working from home. So I believe that you're joining us directly from the Things conference, which is the virtual conference that's taking place. So how has the conference been so far?
Well, it's going currently very smoothly, actually. We had a keynote yesterday, some live Q&A session, a lot of attraction on our virtual booth. We also hosted two workshops, one about STM32WL security and another one related to advanced programming, let's say. So yeah, for now, it's a real success for sure.
Hey, that's really great to hear. So Benjamin, I believe most of our viewers already know what this STM32WL stands for, but still it would be great if it comes from you. So can you give a small brief on what this STM32WL series of microcontrollers are for?
Of course, of course. So actually, end of 2020, we hit the market with the latest version of our STM32WL system on chip. And actually, I'm saying system on chip because it means that it's in the LoRa enablement world and the LPWAN world. It's actually a world first. Indeed, all the internal technical structure, meaning the radio part, the MCU part, the CPU, the peripherals, etc., are all embedded on the same silicon die, which makes this chip what we call a system on chip. So we are the first company in the world to hit the market with such a product, and this actually brings much more integration.
Okay, so when we say a system on chip, obviously it's going to be compact than the predecessors, and it's going to save us power. It would also have an impact on the BOM. So when we compare this solution with a discrete solution in terms of power consumption, what kind of difference are we talking here? Can we put any numbers on that?
So yeah, so actually, despite the fact that everything is embedded on the same silicon die, the performances that can be reached with such product are actually as good as what can be achieved with a standalone implementation. So in terms of radio, for example, we could mention 4.92 milliamp in receiver mode, maybe 15 milliamp in TX mode at 10 dBm when using LoRa communication 868 megahertz, or maybe 87 milliamp at 20 dBm. And of course, this is as good as what you could reach with a standalone implementation. And in terms of MCU power consumption, we have our usual power modes, and our general purpose microcontrollers are very famous for this. So for example, in the framework of STM32WL, we're able to reach 1 microamp in stop 2 mode, so super useful to optimize your static power consumption. And also, as usual, we have a standby mode, the shutdown mode, where, for example, in standby mode, you can reach down to 70 nanoamp. So this is super aggressive and really helps device makers to extend the lifetime of the batteries in their applications, which is of paramount importance in the LPWAN world.
So Benjamin, it's been a little more than a year since this STM32WL series has been announced. So what new features have been added to this series so far?
That's right. So end of 2019, we hit the market with the first version of the product whose architecture was actually a single core architecture based on ARM Cortex-M4. And now we recently hit the market with the latest version of it, end of last year, so end of 2020, meaning that the latest version is based on a dual core architecture based on ARM Cortex-M4 and ARM Cortex-M0+. So that actually brings advanced security features for several reasons. First of all, there is actually secure hardware isolation in between the two cores, which leads to 6 levels of security. So much more flexibility in terms of secure implementation, and also other advanced security features, such as, for example, what we call secure key management services, where actually users can benefit from a flash memory area, which is dedicated to storage of objects or keys, or any other object. So applicative keys or protocol keys, for example, can be managed in a secure way. You can derive new keys. You can move your object in a secure way inside the memory. But also we can think of other advanced features such as secure firmware install or secure firmware update. So the ability for companies, for example, to update or install the firmware for the first time from an untrusted manufacturing site. So very useful in terms of you know, in a manufacturing context. But also there is some secure boot to ensure that there is a unique boot entry, and thus ensuring that the firmware will boot at the right memory location. On top of this, there are other hardware security features such as AES, public key accelerators, true random number generators, etc. Okay, so all of this, I mean, in all this latest version of STM32WL dual core comes with advanced security features and much more flexibility for the users.
So it sounds like the security standpoint has been improved a lot than what it was earlier.
Exactly, yeah, that's right, totally correct.
Okay. So one more thing that particularly intrigued me about these STM32WL is that it can support multiple protocols. So does that mean that I can use both LoRa and Sigfox on the same chip? Is my understanding correct? Or how is it like, and what other protocols can we support with this chip?
So that's a very good question. So indeed, in the framework of STM32WL, there is multi-modulation capabilities. So there is LoRa modulation capability, of course, but also GFSK, GMSK, and BPSK. And thanks to this multi-modulation capability, we are able to address LoRaWAN protocol, for example, but also Sigfox. And by the way, for both of these protocols, we provide in our embedded software package called STM32WL the source code for both of these stacks in a free of charge way. But also, as you mentioned, there are other protocols that can be addressed with the product, such as wireless MBUS, for example. We have external partnerships for this with the German stack provider Stackforce, for instance. But also we can think of other protocols such as Zeta Mesh protocol, currently where there is a porting currently ongoing for WL. And actually, in a daily way, we face customers who need to have, on the one hand, the LoRaWAN protocol implementation on STM32WL, but also the implementation of their own proprietary protocol on STM32WL. And thanks to this multi-modulation capability, this is something which is totally feasible. Or you could even, for example, think of customers who would like to implement LoRaWAN protocol and Sigfox at the same time on the same device. All of this is totally feasible. You have full flexibility with STM32WL because the platform itself remains always open.
That's like really interesting to hear. I think many people would be interested, like if they want to support multiple protocols on the same device, I think STM32WL would be a very good choice for them. So my next question would be about the worldwide compatibility. So speaking about LPWAN, there are different frequencies for different part of the world. There are different power regulations. I think in India, it's 868 megahertz for LoRaWAN. So if some designer is choosing STM32WL for their devices, how do they work around this?
So yeah, that's right. There's a real need for a worldwide compatible chip, and actually this is something which is also feasible with WL. I mean, WL itself is worldwide compatible for several reasons. First of all, there's a linear frequency range from 100 megahertz up to 960. So you are able to target whatever geographic area that you want in the world. You mentioned 868 in India, but there is also 868 in Europe, 915 in America, or 923 in Asia, 470 in China. All of this is totally addressable with WL. And also in terms of, so the first point was in terms of frequency, but also you need to take into account the power aspect, because the level of power, the maximum level of power that can be used depends on the region as well. And for this, we have a dual power output. So one power output which can go up to 22 dBm, and in such case, this can be used, for example, in America or China. And there's also another power output which can go up to 15 dBm, and in that case, such power output can be used in Europe, for example. The main difference in between the two power outputs is that the 15 dBm one is actually more efficient in terms of power consumption. But both of them are totally programmable from 0 to 22 dBm or from 0 to 15 dBm for the second power output. So all of this make STM32WL worldwide compatible.
Okay, so Benjamin, my next question would be about the market reach so far. So you have been personally overseeing these STM32WL series of controllers right from the launch date, I believe. So let me split it into two things, application-wise and area-wise. So which applications do you see these controllers to be a bit fit for? Who is adapting these controllers very fast? And which part of the world, is it the Asia, or which part of the world is adapting LPWAN very fast?
So first of all, regarding the applications, we can clearly say that there is a big traction from utilities and also from asset tracking and smart logistics. So utilities with a smart water meter, gas meter, electricity meters, etc. In terms of asset tracking in the smart logistic as well, such as pallet trackers, for example. But actually, with the WL, we target all the current LP1 vertical market. So we are also present in smart home, in smart agriculture, smart industry, smart cities and building, of course. So in a daily way, we face customers coming from all these vertical markets. And in terms of geographic spread, actually in all the region, I would say. Of course, the size of the market is somewhat bigger in Asia, but overall the traction for WL is extremely good in all the continents.
Okay, that's good to hear. So let's say if someone wants to get started with STM32WL, so is there any development board? Is there a Nucleo board like ST that always provides a Nucleo board to get started? Is there a Nucleo board for STM32WL series? What are the tools and other development options available if I'm supposed to get started with the STM32WL series of controllers?
Okay, so on the one hand, we have what we call our hardware ecosystem, where we provide indeed some WL-based Nucleo boards. So the part number would be Nucleo-WL55 JC1 or JC2, depending on the region that you want to target. So JC1 will be used for America, Europe, and Asia, whereas JC2 will be rather used for China. So that's the hardware ecosystem. These boards are available from distributors right now. And in terms of software ecosystem, we actually provide some tools, all of them in a free of charge way, from configuration up to flashing. So for configuration, we have, for example, what we call STM32 CubeMX that can be used to configure the pinout of the chip to generate the clock tree synthesis or to trigger the clock tree synthesis, but also to automatically generate some code, which is super useful when prototyping your application when you want to prototype in a fast way. Then in terms of IDE, we provide STM32 Cube IDE, which is based on GCC compiler, but we have also partner IDEs, of course, such as ARMCAD or IAR. And after that, we also provide users with a tool called STM32 Cube Monitor that can be used to perform RF advanced testing, so that users can test their LoRa commands, for example, or test the modulations commands. And last but not least, there is also STM32Cube programmer, so that users can flash their device. On top of this, we provide what is called STM32WL, which is an embedded software package containing plenty of application examples, of course, but also the LoRaWAN stack and the Sigfox stacks, which are both provided by ST in source code format. So all of this in a free of charge way. So we really want to enable a maximum number of users and to help them through their developments.
Okay. So that is it. I'm done with all my questions here. Thank you so much for giving very good answers for all these. I am personally surprised by the amount of data you could pull out of your head just spontaneously on the time. So is there anything else you would like to add on to this interview, Benjamin?
No, I think actually, thanks to your interesting question, I could provide quite a good overview of the product and the ecosystem that comes with it. So I thank you for this.